Don't think we have any viewers though. Okay, 0 viewers. Let's do this. All right, so we're going to go through the 2019 January provincial exam. I have it all printed off. We're going to keep on going through just basically every question by question. If you have any questions, then let me know in the chat. But as if you're watching this as a YouTube video, then just make sure you take note of any questions and then you can come back to it afterwards. So the time is 12:02. I'll basically start right away. Okay, so what we have here is the 2019 January provincial exam. So this would be last year's at the same time frame. We're going to go through it question by question. It's out of 90 total marks. We have a calculator for the first booklet. Obviously formula sheets, and on the back side of my formula sheet we will have a terminology sheet. Just going over the terminology sheet, we have things like describe, determine, evaluate, explain, identify, justify, sketch, solve, state, and verify. So when we're using these are some of the keywords that we can come back to if we need to. Oh, hi Sam. We're doing math. We're not playing games. Yeah, we're gonna kind of keep on going through this one. And if we need to come back to the terminology sheet, we can. You can read it if you like to. I never really do. Then we have our unit circle. I'm not gonna fill any of it in. I've got it memorized, but you can always use this as to memorize for yourself as well. But we'll come back to this if we need to. With that, basically, we're ready to start going at the questions. So we got our question 1 here. Oh, we got Hui in here. Right on. Okay, we're going to keep on going for this. So we got question 1. Let's take a read of it. It's a calculator question. We got the calculator icon there, and let's take a read of it. I'm just going to try to focus the camera one more time here. See if that makes it any better. Yeah, a little bit. Okay, so we got determine the length of the radius r, given the arc length is 20 meters and the central angle is 160 degrees. It's out of 2 marks and it gives us our diagram right here. So you can kind of see from our diagram that it's giving us that this entire arc here is 20 meters. We have a central angle is 160 and then it's asking for the radius. When in doubt, you can always look to the formula sheet if you need to, but the very first formula that you're going to find on there is S is equal to theta r. Now the thing that you got to remember is that theta has to be in radians. So right now our theta is not in radians, it's in degrees. So theta is going to equal in 160 degrees. However, we are going to have to make that into radians. So we're going to multiply that by pi and then divide it by 180. You do have a calculator, so you can go ahead and use this. I'm just going to keep it in exact answers right now, and I can always just go back later on to do it. We don't know what our R value is, but we do know that our S value is 20 meters. And we basically have everything that we need to right now. Plug it in the formula. Let's go. I'm just going to do a factor of 10 right away, and then R. So then solving for R, I'm going to flip it over to the other side there. We're going to have it that it is 20 multiplied by 18. And then divided by 16 pi. You don't have to do it all in this many steps. You can kind of go right for it if you'd like to. Calculator does not have to be in like radian mode or anything like that. You can put it in as you see it. So let's go 20 multiplied by 18. And then we're going to divide that by 16 pi. Open bracket, 16 pi button. Close brackets, and there you go. We're going to go for 3 decimal places minimum. We don't want to go anything less than that. We don't want to really go any, we can go more, but we don't want to go any less than that. So let's go 7.16. And I'm going to just give, I feel like giving 4 right now. So I'll do that. And that would be in meters. If you wanted to, you could just do 7.162 meters as well. I'm going to box off this one because I like it more. That's it for a radius. 2 marks. Did it bleed through? Ah, man, it bled through. Why did I use markers? Oh, well. We'll have to keep on going with it. Okay, so we got question 2 here. Another calculator. It's a 1 marker, so it shouldn't be that difficult. But let's see what's going on with this one. There are 8 cars parked in a row. Determine the number of possible arrangements of these 8 cars if Mrs. Jones always must park in the 3rd spot and Mr. Rodriguez must always park in the last spot. You could just go with like sort of do this in your head and write it down. It's only worth a mark. We're only really interested in the answer. I see 8 cars, 8 spots. I'm just going to put 8 tiles down on the ground or on the paper. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to use fundamental counting principle for this. I'm going to recount 1, 2, 3, 4, 5, 6, 7, 8. Yep. So 8 cars parked in a row. You should kind of be able to determine that, order matters here. We're using cars. They're all distinguishable. So we're going to be using the fundamental counting principle. Determine the number of possible arrangements of these 8 cars. Miss Jones always has to park in the 3rd spot. So if I'm going to label this as my first and then kind of working my down that way, then on my 3rd spot, Mrs. Jones always has to park there. Yep. So we only have 1 available option for our 3rd spot. And Mr. Rodriguez must always park in the last spot. So we're going to have a 1 over here as well. Now you could be like, all right, well, wouldn't the 3rd spot, if you're looking at the reverse way, then wouldn't the 3rd and last spot be different? We're just choosing this to be my first and then going this way. We are allowed to do that. That's okay. So we don't have to worry about any other arrangements. That's fine. After that, we're just going to say, okay, how many other cars do we have? Well, we've used up 2 cars with Miss Jones and Mr. Rodriguez. So then we're going to have 6 more available cars. So we're going to have 6, 5, 4, 3, 2, 1. You wouldn't want to leave your answer like this. You would say that your answer is 6 factorial. And since this is a calculator-based question, you can, and you have your calculator, you can do that. Hey, Wee, how's it going? If you got any questions, just let me know. I kind of look at the chat periodically, so I think we should be okay if you do have any questions like that. So in my calculator, 6 times 5 times 4 times 3 times 2 times 1, 720. If you do have a factorial button on your calculator, feel free to use that. Mine just takes like 5 menus to get through, so I just don't really care too much. So 720 ways. All right, so 2 questions down. Let's keep on going. Okay, so we got our log or exponential word problem. Usually you always have 1. Oh crap! I have somebody at my door. Okay. Why don't we put a 1 for the last spot? Why don't you put a 1 for spot 3 in the last spot? Thank you. Okay, I'll get the door in a second. We put a 1 there because that is where Miss Jones always has to park. There's only 1 option for her. And Mr. Rodriguez must always park in the later spot. So basically, that's my restrictions there. Have to handle them first, and then everybody else gets kind of placed after that. Okay, let's keep on going with this one. So here's our exponential word problem. Usually all of our exams have at least 1 of these. So I don't know if this one is going to or not. It's always good to prepare them, and there's a lot of different ones, but they're always going to give you the formula for this. So let's take a look. Bill wins $1,300,000 in a lottery and invests the entire amount at an annual interest rate of 2.5% compounded quarterly. He will withdraw $10,000 at the end of every 3 months. Determine algebraically the number of withdrawals, including the partial amount that Bill can make until there is no money left. Express your answer as a whole number. Use the formula, and then we got the formula there. So to have our formula, we have everything here as well of all of our variables. Now, just make sure you know that our little I in the formula is annual interest rate in decimal form. They're really making sure that you know about that. And then divided by the number of compound periods per year. I have a cat on my desk. Hold on. I don't know. Okay, so let's keep on going. So let's kind of put down some stuff that we know about the question. First off, we know that we have a present value. PV is going to be his total amount, $1,300,000. We know that R, he's going to be withdrawing 10,000 at the end of every 3 months. We don't know how many times he's going to be able to do this, so our little n is a question mark. And then we have our capital I, our little I. Annual interest rate in decimal form, 2.5% as decimal is 0.025. You can just divide that number by 100 and you get that. And then we're going to divide that by every 3 months. So you have to ask yourself, how many times can we put 3 months in a year? And that is essentially the equivalent to saying quarterly. So we're going to put 4. With that being said, we basically have everything that we need. We can actually put it into our formula and we can kind of do some work from that as well. So let's do that. So I'm just going to plug it in. One minus, and it's going to be 1 plus. I'm just going to leave it as I right now. I'm going to actually put in I afterwards, but I don't want to run out of room. Minus n, all divided by I. And I'm going to make this a calculation over here. So we're going to calculate what I is. We can put this all in. We can do a little bit of simplifying as well. Divided by 4, just so I don't make any errors. 5. And if we did this, we would get at least 1 mark in the question. We're going to continue on with this one. I'm going to actually multiply the I across, and then I'm going to divide by 10,000 as well. So we're going to say 1,300,000. And I'm actually going to multiply this by little I, and then divide it by 10,000. And this is going to equal 1 minus 1 plus little I, negative n. And again, I'm just not writing I because it's kind of like an ugly decimal to put in there. Anyways, I'm going to do this work with my I. So we got 1,300,000. Yep. I'm going to multiply that by 0.00625. Then I'm going to divide that by 10,000. Good. How'd you get 4? You mean the 4 up here? So it says every 3 months. Yeah, so it says every 3 months. And if you look at every 3 months in a year, there's 12 months in a year. So if he's doing that every 3 months, that means that he gets to do that 4 times every year. And that's what we need to put for the number of compounding periods in a given year is going to be 4. So that's kind of what we mean for that. Number of compounds per year equals 4. Okay. If it was like annual, then it would be 1, semi-annual 2. There's lots of different words that we can use for that stuff. Okay, so what I got from this after doing my calculation was 0.8125. Now, technically, what you could do is just keep it as an exact, and you just really, what you don't want to do is you don't want to have 3 decimals. You want to keep all your decimal places because this is not your final answer. So you want to keep on going with it. Let's keep on going. So we have this equals 1 minus 1. That's my cat. Yeah. Okay. Hardy. Yeah, you're sitting on the exam now, buddy. Yeah, come on. Okay. Let's go back. So 1 plus I negative n. Okay, so now we're at this point. Let's just keep on going. We're just really doing some simplifying work now. So I'm actually going to put in what I is. So what would that answer that we calculated so far? Not sure what you're talking about right now. If you're talking about this guy here, That's just this side of the equation. Yeah, we're isolating for n, correct. That's the one that we're actually solving for, yeah. So we have this right now. I'm just gonna actually do a little bit of work, and I'm gonna put in what my little I is over here and just kind of get what this is over here. I'm actually going to take away 1 from both sides as well, just because I need to get inside this bracket. So I'm just gonna do a little bit of more work over here. This could be done on like scrap paper if you wanted to. You wouldn't have to really show any work of what's going on here. And you could see like on my page, I'm just minusing 1 from both sides. And then it's 1.00625 to the power of negative n. So again, just in this step right here, all I've done is that I've taken the 1 from both sides. I've minus 1 from both sides to get down here. And then I've just filled in what 1 plus I is for my inside. And then I have the negative out there. So just going to keep on going with this. Looks like I'm going to run out of room over here. That's fine. I mean, whatever, that's okay. So I'm just going to kind of bridge my work up here. If you could, maybe just kind of do something like that. But anyways, we're going to have a 0.1875 equals 1.00625 to the power of negative n, just like that. I just took away the negative on both sides. So you can see the negative over here, the negative there. I just canceled them out to get this. We're kind of almost there. Not quite, we're almost there. We are going to log both sides. I'm going to log both sides. You could ln both sides, you could log base, whatever. But remember, this is a calculator question. We're trying to evaluate stuff. So I would either choose ln or I would choose log, because that's the button that you actually have on your calculator, ln and log. So I'm going to just log both sides. Let's say this is a log of 0.1875 equals. I'm actually going to do the power rule right away. So I'm going to log this side, but I'm going to actually take down that negative n as a coefficient right off the bat. And let's see if I can fit this in. I doubt it, but let's see. Log. Oh boy, you're going to see that I'm just going to kind of do this. Where's my smartboard when I need it? Let's just kind of make sure that we kind of bridge this over. Yeah, not the worst thing I've seen. Once again, I'm going to keep on going with this. I'm just going to isolate for this negative n here. So I'm going to divide both sides by the logarithms. You would get another mark for this right there. And then your final mark is coming from actually evaluating what this is going to be. Log 0.00625, and this is all equal to negative n. Okay. At this point, then I basically can just keep on going. I have my calculator here, so I'm going to actually start typing this in. Okay. Correct, Silver. Yep. You use your log rules to isolate for it, and then now it's just kind of like, okay, go ahead and solve now. So let's go log 0.18 divided by log, using all the decimals. Perfect, I get a negative answer, which is great. So I get negative, and I'm going to keep all these decimals. 7.23484 equals negative n. And then we should know what n is going to equal then. N equals, now remember, what they're going to say is determine algebraically the total number of withdrawals, including the partial amount. Interesting. They're going to actually say here, including the partial amount. So we are actually going to leave it in terms of that Bill can make until there's no money left, right? So we are actually going to, this is our including partial amount here, because you can see that that's like our partial amount of takeaway. But now it's wanting to express your answer as a whole number. So if he wanted to take out every single like drop of money from that, he's going to have to take out 269. So that's how many times that he can take out the money. There's no like units or anything to this. That's just how many times that he's going to be able to take out money so that he has absolutely nothing left. Okay. That last little takeout that he does, it won't be $10,000. It will be a little bit less than that. But that's how many withdrawals that he can make every 3 months. It's for a long time. It's a lot of money though. Big question. God, that was a big question, but done. So good. Got any questions for that one? Again, kind of make like a mental note about that. There's lots of these ones that you guys can do. Only a couple more calculator type questions on this. Here we have, it's a determinant simplify and it's a binomial expansion. So for this one, you know what? I don't even know if I've memorized the formula. Maybe I have, but whatever. What's the harm in going towards it? We are going to be using this formula right there for our binomial expansion. So I'm actually just going to copy that down just so that I don't have to keep on going back. So I'm going to say k plus 1 is equal to n choose k, a to the power of n minus k, and then b to the power of k. All right, so I just kind of basically I've just copied it down. You can really do this question in any way that you want to. I'm just going to keep on just kind of the way that we've done it in class. Whereas I'm going to say, all right, let's just start to get some things here. We know that my a value in this case is going to be x to the power of 3. That's like my first term. My b value, and it looks like I kind of marked it up, but I can see it pretty clearly. It's negative 1 over 2, 2x to the power of 2. So that's my A, that's my B. And then afterwards, essentially, there's not too much more that we have to get. We're going to choose our n value here, or we're going to pick our n value is going to be 12. And that's kind of all that we can do right now. We're going to need to figure out, wait for the other question, how many decimal places do you need to keep in? That's true. I'll go back to that. I'm sure there's a delay in the chat for when we're doing this, but yeah, just let me keep on going here. For our very, very final answer, Silver, we wouldn't have any decimal places because it wants us to express our answer as a whole number. So when we're giving our answer, we would give all the decimal places that we can, okay? Because that's, again, that's not our final answer, so we're gonna give every single decimal place. Or like I usually use the rule of thumb, like 5, at least 5 or something like that. I give them all. But then it said, you know, express your answer as a whole number. So then I came back to this and I expressed it as a whole number. Now the reason why I rendered it up, because it wants all of the money gone. If we kept it as 268 withdrawals, then there's still that like little bit of money inside the account. And he wants it all gone until there is no money left. Okay, so it's just because the answer said express your answer as a whole number. So we're not using any decimal places as our final answer. In the step above, I have it all. Yep, promise. Okay, sorry, back to this. Okay, so we want to figure out then what the 12th term is in this binomial expansion. I have my a, I have my b, and I have my n value. The only thing else that I need to get is k. Now remember, k is that weird one where you have to figure out what term you kind of want to get, and then from that you can figure out what the k value is. So if we want the 12th term, that's not why n is 12, okay? That's because my power is 12. We're trying to find out what t12 is. If you remember, k plus 1 is equal to 12, so that's like the special thing. K plus 1 is equal to 12. And that's because it's this 12. This question is super confusing because it uses like the power and like the 12th term, if that kind of makes sense. But this is where we're getting that from. Okay, k plus 1 is equal to 12, which means k actually is going to be equal to 11. Okay, so that is kind of like a mind screw a little bit where we're having that. So we have our A, B, N, and now we have our K value. So now we can just, basically now it's just like, okay, plug it in and then like do some algebra and do some work on that. Kind of it. These questions are not too bad. I'm not going to say they're throwing 3 marks at you because sometimes they can get a little hard, but if you keep this going, you definitely have at least 1 mark coming in just from doing this. X3, we got n minus k. Oh, that's just 1. And we have negative 1 over 2x to the power of 2, all to the power of k, which is 11. You get 1 mark just for doing that, so not too bad. And at this point now you can just actually use your calculator, which is good. So 12, choose 11. I don't know, I hate doing these in my head. I suppose we could. It wouldn't be that bad. I want to say it's 12. Yeah, it's definitely 12. But you know what? Whatever. Let's do it in the calculator. 12. For mine, I have to go into math. I have to go to prob. Remember, you can't use a TI-83 or 4. You actually do have to use a scientific calculator. This is just the one that I like to use right now. Plus, it's pretty easy to see. But you can't use this one. I knew it was 12. So 12. X to the power of 3 to the power of 1 is just x to the power of 3. That's fine. And then we have this one down here. It's kind of awkward. It's not terrible, but whatever. We're just going to compute it anyways. I'm not going to worry about the negative. It's to an odd power, so the negative is going to stick. 2 to the power of 11, though, that's kind of a nasty thing to do. 1 over, and I'm leaving it in the denominator because that's where it is, right? There isn't any change to it. X to the power of 2 to the power of 11. Power to a power, you multiply. X to the power of 22. So we got that. Got to keep on going, basically. So we're going to have negative 12 x to the power of 3, all divided by. And your third mark is coming from just simplifying the following. I wonder. Probably. Definitely. Yeah. Doesn't work at all. So I'm going to do half of it then? Sure. Let's do negative 6 over, that would be 124. Yeah, so I'm going to be able to do a little bit more. X to the power of 19. Just using some exponent laws here with the 3 and the 22, just taking 3 minus 22 and then leaving it in the bottom. Looks like I can keep on going here. So I will do negative 3 over 512. X to the power of 19, and I do not believe that that wouldn't be divisible by 3, so that's my final answer. T12. Okay, so binomial expansion, not terrible, not like super easy, but as long as you can get this stuff here, not too bad. Okay, yeah, put this one away. And I think this is the last calculator question. So 5 questions for calculator. There is more in this booklet, but that was all that you absolutely needed the calculator for. So let's keep on going. Solve algebraically, calculator question, another 3 marker. So we have this. A couple things right off the bat. I noticed that it's using the natural E. And it has a 7 on this side, but there's nothing I can do to get them down to the same base. Plus it's a calculator question, should indicate that you're going to have to do that. So we can still reduce the even number if we can't change the x power. So we can still reduce the even number. I'm going back to this one. We can still reduce the even number. Oh, the coefficient. I'm gonna assume you mean the coefficients. And yes, the coefficients are separate from the variables in terms of exponent laws. I can reduce the coefficients. Oh, even if we can't change the x power. Yes, you're right. Yes. We would still try to reduce it down all the way because it does want us to simplify, right? So we want to simplify it all the way down. So we did the x here. If we didn't, if the x couldn't be, then that's fine, but we would still do our variables for sure. I hope that answered your question. Let me know. Okay, let's continue on with this one. If you got another question on that one, I'll come back to it after this, but let's keep on going with that. Okay, so let's keep on going and let's do this one. Now, what I'm seeing immediately is to ln both sides. The reason why I'm going to be lnning both sides and not log base 7 for a couple reasons. I can't program my calculator, or I can, let's say that I can't or whatever, program my calculator in base 7. Some of you might be able to, which is awesome, so you could do that. However, there's already a ln thing on your calculator, so I would just use that instead. Now it comes logarithm rules. So we ln to both sides because I saw that we have an e there. Bring down the powers. And now these are acting as coefficients, right? Doesn't matter that they're in a binomial, they're still a coefficient. So we're gonna have to distribute them. Okay, a little bit of a crossroads what we can do right now. We can actually calculate these if you'd like to. This one's super easy, that's just 1. If you wanted to put in the decimals for ln of 7, you could do that, but you gotta leave all of them. Like seriously, you have to leave all of them, because if you get a rounding error, it's because of that. I'm gonna leave them as exact answers, just because that's how, it's just more comfortable for me to do that, and I'm okay with that, punching those in the calculator. But if you're like, this just scares you, put it in your calculator, that's fine. It's a calculator section, you gotta get a numerical answer anyways. Leave your decimals though, you gotta leave as 5, 6 decimals then, okay? Continuing on though, we're distributing the binomial coefficient, you can call it, through. And now I'm just going to be collecting x's. So I'm going to throw the x ln 7 to this side. I'm going to throw the -3 or the subtract 3 over to the other side. I'm not going to do anything. I'm not going to crack out the calculator yet because I'm going to factor. 2 minus ln 7. And then we're going to isolate for x. Now, sometimes it's helpful, even visually, just to do this, because that's what we're going to type in our calculator. I'm going to show you exactly what that is. Solve always means that we need to get, yes. If we're solving, then that's exactly what we need to do. We need to get a numerical answer for x, or for the variable that we're trying to solve for. Yep. Evaluate is the same thing, except there's no x. It's just like, hey, evaluate this expression. It's usually exact answers, stuff like that. But if you're solving, you better get down to something that x equals and then blank. So ln 7. So you can see that that is my numerator divided by, again, open brackets, 2 minus ln 7. And we're going to push equals. So we got our answer there, 91 point, all the decimals there. We need 3 decimal places minimum for this question. I always just give more just because you're never wrong to give more. So I'm going to say that x is equal to 91.438783111. Sure. If you really wanted to, you could cut yourself off after 3 decimal places and round the 8 to a 9. Just whatever. I'm giving more than enough decimal places. That's it. That's the only thing, the last thing that we needed the calculator for. We still have a calculator for the rest of this booklet, but we don't actually need it anymore. Cool. Okay, powering along here. Sketch the angle, 7 pi by 3 in standard position. So standard position, we're going from positive x-axis and we are rotating counterclockwise or clockwise, doesn't matter. We just got to go start from the positive x-axis. I know that this is over 2 pi, right? So automatically, I already know that I am wrapping around. Now, 7 pi by 3, well, that's the pi by 3 family, and we're in quadrant 1, right? The coterminal angle would be pi by 3, so we're up here. You got to put the arrowhead, and you got to have it in this direction there. We kind of give a little bit of leniency of where you have to do that, but that's it. Yeah, you're allowed to use the calculator in the rest of the booklet for booklet 1. It's just, you can see that there's no calculator, like little icon, so it means that you aren't required to use it. For all the other questions, like, yeah, right, you're not going to be able to solve those ones if you don't have a calculator. You know, you just wouldn't. So for these ones, you can still do this without a calculator. I mean, I don't know how I would use a calculator for this question, but you have it available to you. The reason why they do this is because it could help you with something like graphing. right? If you wanted to just kind of do like crush out a table of values, you're wasting a lot of time if you do that, but it's there. So that's done for that guy. Yeah, let's keep on going here. Question 7 then. So determine algebraically all of the zeros for the polynomial function blah given. Okay, a lot of us are going to miss something here. There is something that is very easy to take out, and that is an x. So we're going to say that p of x is equal to x, and we're going to open that bracket right away. And we are going to factor out a value of x. And really, the question now becomes, factor this thing. We're going to factor that now. So don't try to revert back to, grade 10 or something doing, I don't know, like binomial stuff. There is some cool stuff that you can do with this that I haven't shown you that are just kind of like awkward, weird factoring techniques, but I think we should just go standard and just go factor theorem. Let's see what factors of 20 will make this thing 0. So I'm just going to break out 20 here. We're always going to choose plus or minus 1 first, and we're just going to keep on going with that. Zeros, remember zeros is another way for saying like the x-intercepts if we were to graph it, but really it's talking about the roots of the equation. So we're trying to find the factors. That's like, yeah, that would be the x-intercepts. Y coordinates, nope, we don't want those. We're really just looking for x coordinates that would make y 0, right? That would be the zeros of the graph. So we're going to set our, well, we're not going to set p. Oh, I don't have an eraser, so I just have to kind of scribble that out. But we're going to actually try to factor out our trinomial in here. Can you explain question 6 again? I miss it. Okay, yeah, I'll go back to question 6 just after question 7. Okay, so we're going to factor this guy. We're going to have to figure out what can go into this. I'm just going to go ahead and just use, I know 1's not going to work. I could try to use 2. Let's just see. I'm just going to label this as something else right now. I don't know. I'm going to label this as hx, just because I'm going to use factor theorem to see. So I'm going to say h at, let's go with 2. I have a hunch here. I just have a hunch here that this is going to work. 2 to the power 3 minus 5 times 4 minus 4 times 2 plus 20. Okay, this is going to break out with that. Yeah, it totally works. Okay, 2. 2 is a good factor of this purple thing in here. So we're actually going to do some synthetic division with it. You could try 1, you could try -1. I just kind of saw that that's not going to work with the combinations of the coefficients, so I was just going to jump right to 2. Yeah, feel free to do as many as you need to, but with practice you get better at them. I'm going to bust the coefficients down. 20, drop the 1, 2 times 1, 2, -5 plus 2, -3. You can kind of see what we're doing here. We're just carrying along, and bada boom, we got 0. Good. What this means is that I have a polynomial. That's my constant. That's x squared. So right now, what px looks like is, you can use pretty much any other technique that you want to. Determine algebraically, you do not have to use synthetic division. You can use polynomial long division. You can use kind of like weird oddball factoring if you know of other methods. That's okay too. It's the process. You just have to use a process to factor. That's all. X minus 2, x squared minus 3x minus 10. So after factoring this purple stuff up here, what I see is that I got a binomial of x minus 2, because remember 2, when I put it in for an x, it gave me a remainder of 0 for this. Synthetically divided, and I have that over there. Not quite done yet. I do need to see if this is factorable. It is indeed factorable. You can do work off to the side if you want to, but this is like a grade 10 level of a factoring question. I believe a -5 and a +2 will do it. X minus 5, X plus 2. Really quick work, that times, that times, that times, that times, it works, yes. And that's P of X. So you get 1 mark, 1 final mark down here for the complete factoring. You would get 2 marks if you got this, but then you would get the final third mark to get to the final answer there. Half a mark, I believe. So after you synthetically divide, we have to simplify the factor as much. Yes, correct. We have to determine it all the way. The last thing that we have to do here is, remember it's saying determine algebraically all of the zeros of the polynomial. So if we're determining those zeros, we got to go 0 equals x minus 5, x plus 2, and then x equals 0 from that guy, 2 from that guy, 5 from that guy, -2. These are considered all of the zeros for x. Right? Finding zeros. This would be like the way that you would find like x-intercepts is finding zeros, is finding roots. It's all the same thing. We factor them so we can find our zeros. Yes, correct. Okay, so that's what would be our final answer of there. These are all of the zeros of P of X. Okay, I was going to go back to question 6. If we have a question about this, I can come back to it as well. But question 6, I think you just missed it. So all we're doing here is we're just graphing or sketching, sorry, this angle. You can see that it's in the pi/3 family, but it's 1 revolution past 2 pi, if that makes sense, right? 2 pi would be 6 pi/3. So we have to go, how many more pi/3s do we have to go after 6 pi/3? Well, we only have to go 1. A lot of different ways to do this one. Essentially, this is coterminal. Coterm with pi/3. So we would just have to really go pi/3, but then just make sure that we do this extra little spiral, arrowhead and an arrowhead. We have to have those arrowheads or else we will get a communication error. Okay, so I hope that's good with question 6, and I hope that's good with question 7 as well. Okay, let's keep on going. Ooh, we get our first justify question. Justify why 4 of the terms in the binomial expansion (-x plus y to the power 6) are positive. We can do a lot of different things with this. Remember, justify here means that you don't have to explain it in words. Oh, how did you have 6 pi/3? We 6 pi/3, that is 2 pi, right? So if we're going to find a coterminal angle, we would minus a form of 2 pi from it to figure out what the coterminal angle was. I just know that 6 pi/3, that is equal to 2 pi, which is 1 full revolution of a circle. Okay. Yeah, back to question 8 here. Justify why the 4 terms of the binomial expansion is this. I was just kind of saying that when we have things like justify, we can do math and then we can come back to and using that to support our answer. We don't have to explain it, if that kind of makes sense. So what I notice here is that if we have n is equal to 6, that means that there are 7 terms. It's always n plus 1 terms. 1, 2, 3, 4, 5, 6. Justify why 4 of these are going to be positive. Well, just not with a negative sign in front of them. Well, let's just see if we can maybe get the first 3, and maybe there's a pattern here. Who knows? But remember that we're going to get, our first one is going to have all of the power, right? From our patterns of binomial expansion, our first term, a, is going to get everything for the power 6, and y is going to get 0. Our second one is going to have -x, but it's going to lower the power by 1, and then y is going to increase by 1 because everything has to add up to 6. Keep on going, we're going to see some stuff. Anyways, this here is going to be a positive term. We have a negative term to an even power, so it's going to be a positive term. Here we have a negative term to an odd power. And I'm willing to bet that if this one is over here, we're going to have a negative x to an even power, y to an odd power. This is still going to be positive, and we're going to see that we are going to get 1, 2, 3, 4, 5, 6, 7. Duh. We're going to get negative, positive, negative, positive due to the repeating nature. Ooh, let's see if I can get that in the frame. So at this point, we really just have to make a little bit of, you can memorize it. The formula, the only formula that they're given to you is the one that we used from before. There isn't any other formula. So all of the patterns, all of that kind of stuff that we talked about in class, that's up to you to kind of memorize. You can't have a formula for that. So just knowing like Pascal's triangle, that type of formula, and that type of pattern, that's something that you need to do for that. But anyways, we have a repeating pattern. And that's all we need to see. Pattern, so only 4 terms are positive. You could say something like, as it is shown, the positives and negatives alternate. You could say like they alternate due to the pattern, and since the first one is positive, then our last term would also be, because there's an odd number of terms. You can make a lot of justifications. Essentially, as soon as you show us like this, you just have to be like, oh, repeating pattern, so there's going to be that. Would giving an explanation be sufficient answer for this question? Essentially, yes, it could be. Your explanation would have to say a couple things. So if you didn't show it like this, then your explanation would have to be, okay, since my first term in the binomial is negative, then and negative, and we have an even powered binomial, my first term will be positive, and therefore my last term will be positive. And since there's an odd number of terms, or 7 terms you could say, then there would be 4, exactly 4 terms would be positive. So you could do an explanation. If that's easier, go for it. This just seems to make more sense for me in my head. So I would do this and then just give my little thing here, my spiel, I should say. And at the end of the day, it's 1 mark. Don't spend 20 minutes on it. But yeah. Okay, cruising. Okay, question 9. Determine an equation of g of x in terms of f of x. This kind of goes way back to when we did transformations, way back. So let's determine this equation. We have in terms of f of x. Determine the equation of this in terms of that. Okay, so we got to apply transformations to f of x to make it look like g of x. You should be able to see something straight off the bat. There's definitely going to be some sort of vertical reflection going on. I'm just going to kind of keep track of these things. There's a vert reflect. I can kind of just see that because we can see that this is going to be kind of transferring over there. It doesn't look like there's any horizontal reflection, so that's good. But let's try to now kind of see some other things here. I'm looking at a couple different things. I'm looking at the distance between these 2 points, and I'm noticing that that's the same as this. So it doesn't look like they have stretched this graph at all. So it doesn't look like there's any a vertical stretch. I'm looking at the distance between these 2 points over here and these 2 points. Or you can look at the horizontal distance between these and these. Doesn't really matter, but again, they're the same. So there's not going to be any horizontal stretch as well. So really what we're doing here is we're playing with vertical reflection, vertical shift, and a horizontal shift, if anything. So let's do a vertical reflection, and let's just see where we get from that. So I'm going to do this transformation. 1, 2, 3, 1, 2, 3. This is 1, 2 from that and over 1, 1, 2, and there. This guy's down there, and that looks like that. You got to make the sound effects there. So that would be if we just did a vertical reflection. Now we can probably see exactly what we got to do. We got to pick this graph up and we got to move it over this way. 1, 2, 3 spots. There's definitely a horizontal shift now. There's an H shift. And it looks like it's to the right, 3 spaces, 1, 2, 3, plus 3. So we got to just now put this all into a nice tidy package. Gx is equal to vertical reflection, negative, f, open bracket, x minus 3, close bracket. You got to put f there because it says in terms of f of x, a vertical reflection goes outside the function notation, and we have an H shift of plus 3, so we say a minus 3 inside. And you would absolutely never answer your phone during the exam, but I am right now. Okay, yeah, so that's just my mom, so I'm just, sorry, Mom. So we're working backwards. Yep. This is what we need to get to, and this is what we have to start with, so we are going to try to make this into that. Exactly. Anyways, 2 marks, 2 transformations. You shouldn't be looking for more than 2. Does that kind of make sense? Like, it's worth 2 marks, and you got 2, stop, right? Don't try to look for more. Yeah, I'm just trying to think if there would be more equations that could happen. I don't think so. Sometimes there are, but I don't think in this case there would be. Whatever, we can look at the marking guide later. I kind of have it there, but I don't know if we're going to use it or not. Hey, we got a proof. Right on. Okay, let's do a proof. Okay, so prove the identity here. We have, which one looks harder? I think that looks harder. I'm going to do, yeah, so we're going to lock the other guy in place, and we're going to work with this guy. Yeah, okay, I got a good game plan now. Okay, so we're going to work with the other side. I'm going to get my 1 mark. I'm going to get my 1 mark right off the bat by just putting in some substitutions. So sine x plus sine x over cos x all over cos x over sine x plus 1 over sine x. 1 mark in the bag, right on. Don't do this on the exam, or you could do this if you'd like to. You don't have to. Sorry, that's what I meant to say. You don't have to do this on the exam. Man, if you do that on the exam though, like MVP move, because it makes our lives so much easier to mark. We are going to combine these fractions. Common denominator is cos. So we got sine x, I'm gonna have to slam the cos x over there, plus sine x all over cos x. So that's just my top. Big division sign. I already got the common denominator, so that's pretty OP. Looks good so far. Yeah. Okay, now I have to kind of like, this is called a complex fraction. I have to uncomplex it. I've got to uncomplicate it. Do the work off to the side, that's fine. I know what these are going to be, so I know that it's this fraction divided by that fraction, and all I'm going to do is do the reciprocal multiplication. It's going to end up being this thing here, where we're going to get a cos x sine x plus sine x all multiplied. Oh, and I forgot to do the thing here. Where was I? Multiplied by sine x. That was like my denominator being multiplied by numerator up here. And then on the bottom, I'm going to have cos x being multiplied by cos x plus 1. Like that. Okay. All right, so now let's see where we're at. Let's see if we got anything decent here. Okay, so check this out. I see a couple things. First off, I see this. I have a sine x here. I have a sine squared x that I need to get to. I do potentially have another sine x that I can factor out. On the bottom, I have a cos x. Hey, I got a cos x over there, but this cos x plus 1 is kind of like screwing me up a little bit. So let's factor out what we see here, and let's see what happens. Oh, purple marker. And we will see something magical. There we go. Am I still on? Yep. And bing, bang, bada, boom. Kind of ran out of room, but the markers will understand. We got it. Hooray. And I'm just going to say equals right-hand side. Cool. Yeah, difficult. I mean, not too bad, but 1 mark. And then where would we give another mark? We would likely give another mark right down here for like the algebraic process, and then we give you the, or maybe the logical process, and then the algebraic mark would come from this to get to that one. So 3 marks, 1 mark in the back, and then kind of like that. Not a bad proof, not bad. Are there other ways to do it? I mean, I'm always impressed when I find other ways to do it. I don't know. My mind works kind of like one way and that's it, but there could be other ways to do the proof. All right, let's keep on going. Okay, question 11. Given the point, do we have to state? Just do it. Just do it. You wouldn't have to put the like LSH equals RSH, but I would certainly at this point just say that it's equal to that. You're just reaffirming that the thing that you got is indeed what the right-hand side was, kind of thing, you know? It takes no effort for you to do that, but that's all you gotta do. Did you plug in from the, no, I never used the formula sheet whatsoever. There was nothing here that even on the formula sheet, to be honest with you. I didn't use Pythagorean theory. And the trig identities for cosecant and cotangent are not on there. All permissible values, it's a way for just us as mathematicians to say that, hey, this is an identity. It's going to work for literally, for all permissible values of x, this is always going to work. Okay, yes, there are some values of x that, you know, you can't have for cosecant x, but we're just saying that prove this for x in general. That's all that we're kind of saying. We're not asking you to do any non-permissible values, right? Then you would have to do extra work. But it's just kind of a way for us to say, hey, this is an identity and just prove it. It's kind of like covering our mathematical asses, if that kind of makes sense. It's just proper form, if that makes sense. Yeah. No, and I did not use anything in the formula sheet. Hope you heard that. Okay. Repeat again how you got from step 4 to 5. Yep, I can. I'm going to assume that you mean step 1, 2, 3, 4 to 5. I'm going to assume that. So what I did here is, you could see, I factored out another sign. That's pretty much it. I factored just that. So I factored out a sine x, and I got a squared over there. And then I found that this, after I factored out a sign, was the same as the denominator. 3 to 4, you mean 1, 2, 3 to 4. Ooh. 1, 2, 3, 4. Or do you mean this to this? Okay, whatever. I'm going to keep on going. After I got to the squared term, then I canceled out the top and bottom. You counted wrong. Okay. Did this answer your question, though? I don't know if that answered your question. If you're asking about from here to here, though, then all I did was I just worked off to the side and I just did the reciprocal multiplication. And instead of the division sign, then I did the multiplying sign. And that's just our dividing fractions rule, right? So sine x divided by cos x plus 1. That's kind of what I did off to the side. I kind of did it in my head, but I did it off to the side. The question of we don't have to state what x can't equal. No, you do not. You do not have to do that. We're not asking you to do that, so I would not do that. We would have to say, state the non-permissible values of x. And then that would be worth its own mark, you know? This is just straight up proof. That's it. No, you don't have to state what x can equal. Okay. I think I'll be done with question 10. If you have more questions, I'll come back to it afterwards. Okay, keep on going here. Given the point -2, 1 is on the graph of y is equal to fx, describe how the coordinates of the corresponding of the graph of y is equal to f for x are different. Hey, describe. Gotta be with words. Words, damn it. Okay, can't do it with like math. Don't answer this question in terms of like, it's this point. Doesn't matter. You would have to describe the corresponding point on this graph are different. You can do a lot of things for this. I think it would just be easier to say the x values would be multiplied, yeah, by a quarter. Done, right? Go back to the question and be like, hey, wait, if somebody answered me this question, did I answer them? Like, did it make sense? Given that this point is on this graph, determine how the coordinates of the corresponding point on this graph are different. Full marks. I didn't even give the point. The x values will be multiplied by a quarter. You could state the x values if you wanted to. You could be like, it would then become -0.5 over comma 1, right? You could do that. But if you literally just put the point, 0 marks. You get nothing. Because you're not describing. You've answered the question wonderfully in terms of like what the, I guess like a numerical answer is, or stating what the point was, but you get no marks. You would get full marks if you said the x values would be multiplied by a quarter. You could say divided by 4 if you wanted to as well. And then this is just extra. You could put this if you wanted to, but it's not needed. Kind of fitting in my page, kind of not, but I hope you get that one. 1 marker as well. Okay, moving on. Using the law of logarithms, completely expand the expression. Now you do have this on your formula sheet. I said it once, I'll say it again. Memorize those things. Just make B1 with them. If you're looking back and being like, oh, what can I use with this and that and that? I'm gonna think that you're wasting time for it. That could be used otherwise. These logarithm rules should be something that's kind of like, you know, second nature. If you do the practice, of course. Okay, so we got log, and let's do the first one right off the bat, the subtraction. Subtract. W minus 1. Hey, we got 1 mark right off the bat. Let's do this. It's multiplication. X squared plus log minus log. Can't split up this one, right? There's nothing for subtraction. Hey, we got another mark right there. Last mark comes from power rule. Let's get a plus sign in there. 1/2 log y minus, and there's your third mark. Can you see that's a W? I hope you can. Done. 1 mark, 2 mark, 3 mark. That's it. Okay, let's keep going. Given secant theta is equal to -5/4 and tan theta is greater than 0, state what quadrant theta terminates. Justify your answer. Again, a justify can be math, it can be explanations, or a justify can be this. Secant theta is negative, where cos is negative. So we have negative here and here. Tan is positive, so that means that we're in here. Q3. That's my answer, and check this out. That's my justification. Yeah, so I think I like that one a lot. That's why I like these sign diagrams. That's done. Cos is negative, boom, boom. Tan is positive, boom. Double boom, 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 boom. Easy. Question's done. Love that. Okay. Let's keep going here. Question 14. State an equation of a rational function that has a vertical asymptote, x is equal to -8, and horizontal asymptote, y is equal to y is equal to 9. I'm just reading the comment. You cannot break up log of w minus 1. Correct. There is absolutely no logarithm rule that states what we can do if there's a subtraction inside the argument. It's only if there's a division, which then becomes the subtraction outside the logarithm argument. Okay. Good question. Okay, state an equation of a rational function that has a vertical asymptote that and a horizontal asymptote of that. Cool, there's thousands and thousands and thousands of answers. Let's just go ahead and let's do this. Fx equals rational function that has a vertical asymptote at, I'm going to do that one first, and a horizontal asymptote at y is equal to 9. Well, then I need to make their degrees the same. Right? Yeah, that would be what we have to do. That's it. Yeah, there's no point to discontinuity because I can't factor anything, right? It's got a vertical asymptote, x is equal to -8, because I can't factor it out. The degrees are the same, so I have to divide leading coefficients together. 9 divided by 1 is 9. 2 marks. That's it. Given the point 5, 1, state the coordinates of a corresponding point after a reflection across the line y is equal to x. Uh-oh, we all forgot about that. This is an inverse. They could have asked inverse it. The reflection across, all you got to know is that yx becomes, xy becomes yx. And if our xy was 5, 1, well, we're going to switch them around. 1 mark again. Bing, bang, boom. Done. Easy. I'm going fast because I think we can. Plus, I don't, like, purpose of this isn't for teaching, I guess, but for more like, hey, let's just do a bunch of math. If you got questions on it, let me know though. There's a delay, but I will get to them. Okay, we got these ones. This one pissed off a lot of people if I remember correctly. Yeah, because usually we always use plus signs, so it's like, oh, we know which one to expand because it's like, which one's bigger? Well, if you choose to expand out the top, you're in for a bad time. Because the one that's bigger is actually on the bottom. Because remember, when we expand out, we move down. So simplify, so we do have to do that. That's it. No solving, no nothing like that, just a mark. Yeah, this pissed off some people. I remember this question. But yeah, it was a good question. I like this one. Okay, kind of rapid fire them off, but yeah, we're nearing the end here of the first booklet. And we're like an hour and a bit in right now, so not bad. We would be able to open up the second booklet 45 minutes in. So you're allowed to start the second booklet 45 minutes in. Right. We'll talk more about that later. Okay, given the graphs, y is equal to f of x, boom. Y is equal to g of x, boom. Determine the value of f at g at 2. This is basically one of the things that we have yet to cover in the course. It's one lesson, kind of one-off on Monday, but it's really, really easy. All you gotta remember is that you go inside to outside. That's it. Inside to outside. So the inside, g at 2. Function notation, boom. We look at our g. We find g at 2, 2, 0. So this is equal to 0. So now we say f at 0, because remember, that's on the inside. We go to our f, we see x equal to 0, boom. 0, 1, 2, 3, 4. And we get our final answer as 4. Really easy stuff. I know, like, we haven't done this yet, but really easy stuff. This guy we have done, regardless, maybe some people have done practice or not, but we'll see what happens. Where would you save the vid? I'm going to be uploading it on YouTube later on, so if you got to go, I'll upload it later today on YouTube. It'll probably take a lot of bit, because this is going to be a long video. It'll probably be like 2 hours, something like that. But yep, it'll be on YouTube. I'll post the link on our Google Classrooms. Determine the value of g minus f at -3. Let's do g -3. 1, 2, 3. We're at +1. F -3. 1, 2, 3. Down here, can I read that? -2. So all we're doing right now is we're just gonna say g minus f at -3. We got g at 3. We got f at -3. -2. Done. that's it for the first one. So with that, calculator goes on the floor. We haven't actually used it at all. The calculator goes on the floor, and now you cannot ever access it again, because once you're on the second booklet, you cannot have it. We didn't learn just question A on that one. Like when it's the inside to outside, that's the stuff that we didn't learn. We've learned everything else besides that, like the multiplying, the dividing, the adding, and the subtracting. Yeah, super simple stuff though. As you can see, that's the first time that we've had it. It's worth 2 marks on that exam so far. We should get another question on it. It's worth about like 8-9% of the exam. Not a lot at all. But anyways, we're on second booklet. So let's crush out some multiple choices. Okay, identify the remainder of this when that's divided by that. Excellent. We're using remainder theorem. We're popping in the opposite of what you see in here. So that's an x minus 2, so we're popping in 2. No calculator, right? So if you're like, oh, I can't do this in my brain. Nah, chances are you can, and you just gotta stretch yourself a little bit. 2 to the power 3 is 8. 8 times 3, 24. 2 to the power 2, 4. That's probably a 20, and that's 21, so I hope there's a 21. There it is. Keep on going. Identify the logarithmic form of whatever this is. Okay, cool. So, if we're going to identify the logarithmic form of this, is there like a really easy way to do this? Should be. I want to say there is. Yeah, there totally is. Let's do, just wondering if we can do this easily. See, these questions are fun. Well, okay, whatever. We know this is the base. Base equals 2. So if we wanted to apply a logarithm, we can have the base of 2. Our exponent would be our argument, and our exponent would be our argument, and our answer would be the new. Our answer would be the new. What would be the argument? Damn. You know what? I don't know why this is stumping me, but anyways, I'm gonna break this down. 2. Yeah, okay, so that's not gonna be the answer. Let's go to this one. I'll explain my process in just a second. And then I'll be able to describe it if that makes sense. I don't know, you may be able to answer. Okay, I already just got the answer here. Okay, boom, okay. So the 2 is the base, so that's gonna be the base of our logarithm. Right. The answer is going to be our new argument, and then our exponent is going to be our answer. There we go. I had to like figure that out, the way to say that in the head. Okay, so what we're doing here, and as you could see, what I did is I actually just broke down each one of our multiple choices, and I was just like, hey, if I were to like get rid of the logarithm, what would get me back to like the question? So I kind of like assumed that one of these was the answer. Obviously it is, and then I got back to the thing that we started for. But yeah, see. The base was 2, so we know that that has to be our logarithm base. Our answer becomes our new argument, and then our exponent becomes our new answer. I think I literally said that like in our notes or something like that later on, or earlier on, or something like that. Welcome. Okay, let's keep on going. Another 1 marker. Leah's pretending pizzeria offers 9 different toppings. Identify the expression that represents the number of different types of pizzas with 3 different toppings that can be made. Okay, so the expression that represents the number of different types of pizzas with 3 different toppings that can be made. Okay, so here's a couple things that we want to make sure that we know about. I love these questions because they always screw with you just a little bit. 9 different pizza toppings. Okay, now think of it like this. We're gonna make a pizza, okay? And we need 3 different toppings. If you do this, what you are saying, and then let's just go like 9, 8, 7, okay? What you're doing is first an error, okay? But I'm gonna explain why. This is an error because remember when you put the fundamental counting principles, this is the same as doing a permutation where order matters, okay? Now, does the order matter when we put on pizza toppings? Don't get all philosophical with me on this one. No, it doesn't, okay? cheese is on there, whatever. It doesn't matter if I put like the pepperoni before the olives or whatever, okay? We're not all like pizza artists or artisans or whatever they're called, okay? So the order really doesn't matter when we do this one. So in that case, if we have 9 toppings and we want to choose 3 of them, it's a combination. It would be 9 choose 3. Order wouldn't matter for this one. You could say, yeah, but they're distinguishable. Okay, whatever. But the order doesn't matter. And that's really what the key of the question is. I think a lot of people had problems with this one and probably didn't get it because they did this, but this is actually wrong. This would be the incorrect way to do the question because it would not matter of the order that you put your toppings in. So there you go. Okay. So that would be for that multiple choice one. There's always going to be some weird oddball multiple choices, but you know, take it with a grain of salt. Some of them are easy, some of them are a little more challenging. Okay, given 5, 4 is on this point, identify the point of y is equal to, that's just your transformation. That's an instant answer. It's this guy here. You're taking 1 over y, right? That's it. The non-permissible values of this over that, well, secant x is equal to 1 over cos. And then we know that cos x cannot be equal to 0 if it's on the denominator. Okay, so then that would mean x cannot equal 0 to pi. So we're saying cannot be 1/2. Yeah, that's it. Indicate the combination that represents the circle term in the given row of Pascal's triangle. Remember, no calculator. You don't have a calculator here. So if you just want to bust these in to your calculator, it is not going to work. Okay, so you can use a formula though. That's completely fine. N choose k is equal, and you have your formula. Doesn't mean you can't use your formula sheet. Oh, that's an r. Sorry. N minus r. So if you really wanted to, you can just kind of bust out any one of these, and you can just be like, okay, which one would it be? You could probably eliminate some answers for yourself. Like you can eliminate a couple of these off the bat, but let's just choose one. I feel like I'm gonna choose this one. 5, choose 4. I'm gonna go with that guy down there. I'm just gonna see what happens if I put him in. And I get 5 minus 4 in a factorial. And I get 5 factorial divided by 4 factorial multiplied by 1 factorial, which, remember, is 1. 1 factorial. So I get this to be 5 factorial divided by 4 factorial. I got that to be 5. Okay, well it's not the one I was looking for, right? So let's try again. So that's not going to work. Let's do something like this guy over here. Or maybe you already seen one. Maybe you already seen what the answer is. But let's try another one. Let's try 5 choose 3 now. 5 factorial. That would be this guy over here. And then 5 minus 3 would be 2 factorial. Okay, so I would have this. Now we can do a little bit of work for this, but it's going to be 5 multiplied by 4, and then 2 factorial. I'm kind of just spreading out my work everywhere. This is kind of like mind, kind of like verbal diarrhea, but like on the page, right? I'm just kind of like busting out. You can do this on scrap paper. I don't have any, so that's fine. But again, this is not going to get us that one. So these answers aren't working. Well, you only got 2 more to go. If you really wanted to, you could try doing that one, but you should see that that one's not going to work anyways. So really, let's try out this last one. Let's try out 4 choose 3. 4 factorial over 3 factorial, 1 factorial. And we're going to get that one to be 4. Prove it to yourself, do it into the formula. You could do that. Again, remember, you can always just memorize for Pascal's triangle what you can do for that one as well, or you can kind of bust it out in terms of the formulas. Up to you what you want to do for that one, but kind of like spread out my work all over the page. You can kind of take a look at some patterns and stuff like that for that too. Wouldn't spend too much time on it, but if you memorized what all the coefficients are in Pascal's triangle, you could get that answer right off the bat. Try it out, take a look at the notes and try to go for that one. I just kind of did a whole bunch of formulas because I assume this is what some people would do, but it still works. 3 more multiple choice questions? 4 more multiple choice questions. Almost done the multiple choice. Identify the x-intercept on this graph. Well, x-intercept is when y is equal to 0. Okay, so we got that. All right, well, that's not too bad. So let's now continue. I'm algebraically solving this. Square root of 0, 0, right? Dividing by 2. Kind of just got it right down to that. Now, let's see. Does that make sense? Yep, that's good. You could do it in a lot of different ways. You can do it just based upon like transformations if you wanted to as well. But yeah, everything works like that. Okay, next one. A coterminal angle over this. Oh, that's an interesting one. It's giving me some negative answers, giving me some positive answers. You know, I don't know based upon the look. I'm just going to minus a factor of 2 pi right off the bat. Let's see what happens. Is that one? Hey, that's one of our answers. Not bad. Oh no! I kind of fell into a trap there. I see a question about going over question 20. Yes, we can. But I fell into a trap right here. Excellent. They trapped me. I think that's a trap, right? Yeah, totally a trap. That's outside the boundary. It's from negative pi. So I am not going to be able to subtract a value of 2 pi for that. Ah, good. I like it. So I'm just going to have to add 2 pi. Plus 10 pi over 5. So a 15 pi over 5. That probably could get... could it get reduced? Yeah, I don't know if it would help me though. I don't think so. Yeah, this is a tricky question. I think I have to add another... Do I have to add another 10 pi to it? But that's not one of my answers. Even if I did this again, I feel like I'm missing something really easy. Yeah, that's not going to work. Oh, wait, because I'm silly. I said that pi plus 10 pi is equal to 15 pi. It's actually not. Usually in math, we say that pi plus 10 pi is actually 11 pi. There we go. It's D. Okay. Yes. No, thank you. I got question 20 to go over. So there's got to be like a delay of at least like, I don't know, what, a minute or 30 seconds or something. Can we please go over question 20? Sure. Okay. So let's go take a look at the marking guide. I got it right here. So let's take a look at it and let's see what they said about that one. Question 20. Well, maybe I'm going to eat my own words then. Question 20. I don't know. Ah, man, no, they don't give any explanation. That's crappy. Okay. Let's go over it. Okay. So I'm going to try to explain it again. Okay. 9 different pizza toppings. Identify an expression that represents the number of different pizza types with 3 different toppings that can be made. Okay. So here's the thing. It's using the word different types of pizzas. Okay. So you could be being like, oh, like these pizzas are different, right? Like pepperoni, bacon, and olives are different than pineapple. I don't know why I'm naming off these ones. Mushroom and onion or something. I don't know. Disgusting pizzas, but whatever. They're different, right? The reason why it's a combination is because the order doesn't matter. There's no given order saying you have to have the first topping, the second topping, the third topping. It is a here's toppings and we put them all out. That's it. There's no first, second, third. There's no order to it. It's quite literally just order does not matter. Yes, you can distinguish these pizzas from one another, but that's not the reason why it would be a permutation. Permutation means that first and foremost, order matters. And in this case, order does not matter. That's the best explanation I can come up with because that is how they made that question. They don't offer a explanation of why it is. It's just it's just a combination. Order doesn't matter. I hope that it probably doesn't help you. I know it wouldn't help me if I were in your shoes, but that's the explanation of it. Anyways, going back to 26 right now. This one was a good one too. F of x is equal to a discrete set of points. Discrete. You can see that by using the braces here, and each point is separated by a comma. identify the value of f at 2, and then f at 2. So f at 2, we go to the x-coordinate of 2, and that equals 6. So then we take f at 6, remember, because this is on the inside, and then we say that's equal to 5. This, again, we haven't done this in class yet, so there's one more mark of something that we haven't done, so now we're up to 2 marks of stuff we haven't done, but anyways, the answer is 5. Again, we're working inside to outside, so we got to deal with f at 2 first. We see that the y-coordinate is 6, and then now that becomes my new x-coordinate because that's on the inside. So then f at 6 is then equal to 5. Okay, last one for multiple choice. The graph f of x is equal to this, x minus 1 all squared. It's translated 2 units to the left and 3 units up. I want to just keep track of this. So x, 2 units to the left plus 2, and then 3 units up, y plus 3. That's kind of like my transformation mapping notation, if I wanted to say. Identify the equation of the transformed graph. Oh, right on, cool. So straight up, do the transformation. That's all you got to do. We're going to do a x plus 2, and then we're going to do a plus 3 equals, well, we have f of x, and now we're going to replace the x with x plus 2, because that is a translation of 2 units to the left. X plus 2 squared plus 3, x plus 1 squared plus 3. I hope that's an answer. Heck yeah, it is. Done. That's it. Tricky, but done. Okay. That's it for the multiple choices. Okay, so now we are on the final portion of the exam. This is like, it is the longest one. We're on question 28, and there are 48 questions, 49 questions. So we've got about 20 questions left to do. Time frame, not too bad. Hour and a half in, we've got another hour and a half to go. And this is with explaining. This is kind of with all that kind of stuff. So yeah, not bad. Let's go ahead and let's keep on going here. Given that cosecant theta is equal to negative 8 over 5, determine the exact value of cos 2 pi. Cos 2 theta. Hey, cos 2 theta, I have no idea what that is, so I'm just going to go look to my formula sheet. Just kidding, I have every idea what it is. Let's go with cos 2 theta equals 1 minus 2 sine squared theta. On your formula sheet, speedrun continues, yes it does. The formula sheet gives it to you in terms of alpha, but I mean, you change it into theta. If you did alpha, then you have to say like let theta equal alpha. So you can't just use alpha, you have to introduce it if you're going to do that. Remember, formula sheet doesn't have theta, it has alpha in it. So I'm going to put this down. The reason why I'm using sine is because of this. 1 over sine theta. So we know that 1 over sine theta equals negative 8 over 5. And then now I'm going to get what sine theta is and say that's 5 over 8. Right? So now I get to use that as my exact answer. So cos 2 theta equals 1 minus 2, open set of brackets, negative 5 over 8 squared. Not bad. Still gotta work, right? Exact values. Minus 2, open bracket, 25 over 64. Oh man, I'm gonna run out of room. That was stupid of me. 1 subtract 25 over 32. Just did like a nice little simplifying there with the 2 and the 64. And then we're gonna get 32 over 32, subtract that. I'm gonna have to put it over here. 25, 2. That's a number 7. There we go. And that is cos 2 theta. We are not solving for theta, right? We can't. We don't have a calculator. So we can't do it. Determine the exact value of cos 2 theta. It's not asking us to solve for theta, right? 2 marks. Done. Man, when are we going to get to some graphing? Want some graphing stuff. Okay, determine the period of the sinusoidal function. of the f of x equals -6 cos. Wow, they give you so much information here, and literally all you need to do is period is equal to 2 pi divided by b, and b is that. Pop it in. Pi divided by 6. You know, complex fraction, work it out. Reciprocal multiplication. Pi's cancel out. 6 multiplies the 2. 1 mark. Okay. Blitzing through. Blitzing here. Determine algebraically the equation px given of this graph. Okay. Well, check it out. Degree. It's got to be even because it's ending in quadrant 2 and 1, right? So degree 4. Leading coefficient is going to be positive because, again, 2 and 1 for that one. It looks like we got a multiplicity of 2 here. Multiplicity of 1, multiplicity of 1. Yeah, okay, so this is just straight up. We don't know what the leading coefficient is. We know it's positive, so I'm just going to put a as a placeholder. X plus 2, that's from that guy. X minus 1, that's from that guy over there. And then x minus 3 squared from that guy, multiplicity of 2. Okay, so we have an equation. It's not, that's 1 mark, by the way. 1 mark right here. We do have to use this fact, though. Check it. The y-coordinate is 36 when x is 0. And if you're like, Mr. Morris, we never did that in class. Haha, yeah, right. Go back and review it because it was a long, long, long time ago. And we probably haven't touched polynomials since. 2 times -1 times -3 squared. Oh God, what's -3 squared? That's like a 9? 18a. Should I put a negative in front of that? Yeah, I should put a negative in front of that. So that leads a to be equal to negative. Whoa, 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 whoa. No. I said a has to be, a leading coefficient has to be positive. What's wrong? Something's weird. I should have gotten that to be a positive number. Oh, negative 36. You see, I thought that was a tick mark, and I just read that. I was stupid. There we go. So that's a positive 2. There we go. Okay, keep on going. X plus 2. Man, that was actually a really good thing that I kind of wrote down some of that stuff, right? Up here. Kind of see the worth in that now. It's like, hey, positive leading coefficient. But then I didn't get one, so I'm like, okay, what was wrong? Oh, 36 had to be negative, right? I think I knew that already. But gotta make sure you go back in there. Anyways, you get a full mark just for A, hey? Isn't that crazy? You get a full mark for A, and then you get your mark for knowing that these are the factors of it, with a proper multiplicity and all that good stuff. Or maybe it's a half a mark. I feel like I want to go check now. Oh no, actually, I was wrong. You get half a mark for the correct value of A, and you get half a mark for the substitution of P0. So basically you get a full mark for A because you have to sub it in. So you get half a mark for this and then half a mark for that because it's consistent. But you get the full mark for that with the multiplicity. Cool. Ruh-oh, we have a trig equation now. Luckily, super luckily though, this is not on the calculator portion. So what you can take from that, exact answers. Everything are exact answers, which is perfect because I don't want to use my calculator for this. I want to know unit circle. So let's go ahead and let's see. We're not going to be able to deal with it in this form though. 36 is negative. Yeah, totally. Got it. We're not going to be able to deal with this equation in its current form. We are going to have to factor. So I'm going to do some decomp factoring. 2 and 4 is going to be a -8. -8 can be broken down into -8 and 1, and that equals -7. Ding, ding, ding. That's good. Let's go back there. Sine theta minus 8. Yeah, I'll roll with this one. Sine theta plus sine theta minus 4. You can sub in y equals if you'd like to, but you gotta have to be like y equals sine theta and then make sure you put it back in the end. I'm just gonna deal with this though because I'm comfortable with that. That's okay with me. Doing a nice little GCF factoring here. Minus 4. Making sure that looks right. Yep. Plus, hey, good, we got the same thing. Factor out. I just realized I did this exam. That's hilarious. That's actually very funny. Yes, it is your exam. I don't know who you... Wait, no, that's Jacob. What are you doing on the stream, buddy? Glad you're doing okay. Glad you're wasting your holiday time watching me do more math and the exam that you did. Plus 1 equals 0. Okay, so we got this going on here. Okay, we got 2 answers. We got sine theta is equal to 4. And then we got sine theta is equal to negative 1/2. Let's put that in view. All I did was solve this for theta, so solve that one for theta as well. You actually do have to do this. If you don't do this, you got like I think like half a mark or something off, but you have to be like, no. Like an X is good enough, right? You don't have to do anything else from that. But then from there, we say that theta is equal to a half. That's in our pi by 6 family, and it's in quadrant 3 and 4. So let's just make a little like check. So it's pi by 6 in quadrant 3. Why am I struggling so much with this? It is 7 pi by 6. And it's going to be 11 pi. Can I save this? Yes. Now, here's the big thing. General. It's got to be general solutions. So, plus 2 pi k plus 2 pi k. And I'm just going to say k element of the i's integers. And there we go. You could use degrees if you wanted to. You could. So you could say that this would be, what would that be? 210 plus 360 pi, or 360k, and that would be 300. No, 330, sorry. 330 degrees plus 360k. Because this doesn't indicate that you have to use radians. Right? 4 marks. Wow, they're generous. Should have gotten that one right, Jacob. Okay, let's open that one. Hey, moving along. Justify that the shapes of the graph, this, f of x, and g of x, are different as they approach the x-intercept of 1. Justify. Justify. You have to make sure that you have 2, like, yeah, yes. The easiest answer is just to say yes to that. Don't try to do any, like, weird, I'm going to put 2 answers in 1 or something like that. No. 2 general solutions. The only time that you wouldn't have to do that if it was tan, and then you could just say it was plus pi. But again, if it's periodic on 2 pi, you need to, because there's no relation between the other ones. Okay, let's go ahead and let's do this one. Justify that the shapes? I mean, the explanation is good enough for this. This would definitely be an easier just to explain. The multiplicity of the 0 x equals 1 on f of x is 1, whereas the multiplicity of it on g of x is 3. Okay, that would be good. As they approach. No, you know what? I'm looking at one word in particular right now. I'm looking at shapes. If I said this, the multiplicity of the 0, that's not wrong, right? We all know that this is correct. However, the question, the shapes. I have never said anything about the shapes. So this answer is going to look right, but we're not going to be able to put it. We're going to have to say something like this. Let's do something like this. As x approaches 1 on f of x, it goes straight through. Straight through. Comma. As it approaches, as it goes through on g of x, it levels out. There. Now, what we have done is we have actually said how the shape is different. As x approaches 1 on f of x, it goes straight through. Straight through. As it goes through g of x, it levels out. Oh, I guess we could say it levels out first. Essentially, we're looking for the leveling out, because now you are talking about the shape. If you're not talking about the shape, then whatever you get for these ones are weird. We're comparing the shapes. Yeah. This is completely right. And like, I would even argue that this is like more mathematically, not correct, but more mathematically sound. It sounds like, oh yeah, you really know what you're talking about, using like multiplicity and stuff, and which you should, right? However, it's really indicating that you got to talk about the shapes. So we got to talk about the shape. Straight through, or f of x, levels out as it goes through on g of x. There we go. Oh wow, more trig. I like it. More reciprocal trig. Nope, we don't have to. Do we have to talk about what it does when it goes through the point? I mean, we kind of did. You could say, as long as you're talking about the shape, right? Like as long as you're talking and you gotta say something like this, levels out. Like you gotta say something about how it goes through that point differently. You could talk about that in different ways, but make sure in your justification or description or whatever, you got the leveling out. That's important. All right. Let's do 33. If you got another question on that one, I'll come back to it. Exact value of cotangent theta if cos theta is equal to negative 4/7. And sine theta is positive. Okay. Well, slam this puppy down. Right? We already have this portion. We just got to figure out what sine theta is. But it's positive. So sine diagram, check mark, it's got to be in quadrant 2 or 1. And our information has, it trails the x-axis at, what if you said it trails the x-axis? I would accept it as long as you're saying it still goes through. Like when you say trails x-axis, what I think about is horizontal asymptote, right? Because that's like kind of the terminology we used. But as long as you said it passes through, but trails along the x-axis before and after passing through, that would be fine. I would give you, you could give me a diagram. Hell, why didn't I do that? That was a way better idea than this. You can go like this. fx, you can go like, in a certain way, right? And you can make this in your argument, right? This can't be just it. You would have to go and do some sort of description after this. Woo. Okay, that was a crappy thing, but you kind of get what I'm trying to do here. Something like that. Okay, not enough room for me to do that, but you get what I'm trying. Doing it again. There, that's better. You can kind of give like a kind of a picture to help you out again. That would be fine. That would be okay as well. I should have done that before. Why didn't I think about that? Thought about it afterwards. Okay. Let's go with this. Anyways, we know sine x is positive, but cos was given to be negative, so we know that we're in quadrant 2. So we are going to do a nice little sine diagram. Boom, boom. We know cos theta is x over r. R is always going to be positive. X coordinates negative. We're going to have to do Pythagorean theory, but remember, exact values, so you don't have to, like, you can't have a calculator. So we're going to say that this one is square root, and it's going to be 49 minus 16 49 minus 16. 35? 33. Right? Yep, 33. Gotta leave it like that. Can't do anything more than that. So sine theta equals y coordinate over r coordinate. Sweet. Equals, now we're ready to go back up. Cos theta, negative 4 over 7, divided by root 3 divided by 7. Hey, look at that. The 7s get chopped off. Equals negative 4 over. And you know what? You are not going to rationalize that because you have full marks right now. And if you don't rationalize it, or if you don't rationalize it, you still get to keep the full marks. But if you rationalize it and you screw it up, then we take marks away. So don't do it, right? There's no benefit in rationalizing it. If you wanted to, though, we would also accept this answer. And I will put the big letters of or, but I'm still going to circle that one because I really would. You have full marks. Don't jeopardize that, right? You have full marks. Don't jeopardize. 2 marks, though. Okay. Oh yeah, we're blitzing here. Hey, we got our first actual, like, let's do a graph question. That only took like 34 questions. Okay, we got a log graph. So straight up, we are going to do our XY. Transformation notation. Ain't anything going on with x's. Y's though, vertical reflection, and then a +2. Done, right? XY, we're in y is equal to log base 2 of x, right? That's our base graph, right? They do not take marks off if we don't rationalize it. Correct. You will have 100% marks if you do not rationalize. I hope I said that right. Which is why I really don't want anybody to rationalize, because you're essentially being like, oh, I'll do this, but if I screw up, then we can only take away marks. Anyways, let's continue. What was I talking about? Right. Base here. So when x is 1, y is 0. These are my transformation bases. 2, y is 1. That's all we needed. X is equal to 0 is our vertical asymptote. Let's do a transformation. 1 and 2. 2 and negative 1 plus 2 is 1. And my x coordinate is still 0. Onwards to the graph we go. Hi ho, hi ho. There. Let's go here. Boom. 2 and 1. Boom. There's only really one way to mark these up. Good. Now you gotta state your. No! I did an error. How am I gonna do this? Crap. Big error. Big error. Now I gotta make my graph by myself. Damn. Okay. Luckily, what do we got? Yeah. Nah, I don't want to do that. Screw that. Let's put it back on this. I'll do it better here. We're still going to have that vertical asymptote. X equals 0. If you did this, right? If you did this, like say this was an exam, right? And you're like, oh crap, I did this. And you're somehow using IKEA markers for some reason. This would be like, hey, I need to white this out. Or, hey, you need to really make this new graph really good. So I'm going to tell you what would have to happen if that happened. Horizontal asymptotes are always exponential functions. So I'm going to make my point here. And there. Okay, now check this out. What I'm going to do here, in case of this error that I did, I'm going to label this point as 1, 2. I'm going to label this point as 2, 1. Now, here's the thing. We're going to pass the x-axis. We have to give that point. If we do not give that point, I believe it's like I don't know what it is. I think it's just a procedural error. It's a half a marker. So we need to figure out what this point is. Okay, so this is when the y coordinate is 0. So we actually have to solve for that. Oh my gosh. They're making us solve that. Plus 2. Whip the 2 over. Do you need to do all of this work for it? Absolutely not. You might even just be able to do it like in your head from this equation, right? So it's really up to you of how much work you want to show. You would get no marks for the work, I would say though. Which one has horizontal asymptotes? It would always be exponential, right? So horizontal asymptotes would be any exponential function, 2 to the power x, 3 to the power x, whatever. And same with natural exponent too. So e to the power of x, that would have a horizontal asymptote as well. To the power 2 equals x, 4 equals x, and hey, we got this point to be 4, 0, and we would have to mark that out. So if this happened and I'm writing the exam with IKEA markers for some reason, I say mark this, and hopefully my marker's name is not Mark. It doesn't get confused. Okay. I hope that makes sense. Sorry. Okay. The range. Man, this is just like you look at the question and you're like, okay, we have a radical function, right? And the range of this is 0 to infinity. None of these transformations do anything in terms of the vertical aspect, right? That's horizontal, that's inside the radical. So tricky. Done. That's it. Okay. Sophie correctly solved the logarithmic question like this. Explain why x equals 1 is an extraneous root. Sure. If x equals 1 was plugged into the original equation, there would be a log base 7 0 equals log base 7 of 0, and log base 7 of 0 cannot exist. That's it. Remember, extraneous means like it cannot exist. It's on the vertical asymptote. It's extraneous. It's outside the domain of what a logarithm would be. We can't have negative arguments, and we can't have 0 in our argument. As our argument, sorry. We can't have 0 as our argument, or negative. So if she would plug that answer back in, it wouldn't work. Even though you would get the left-hand side equals right-hand side with, like, you know, mathematically it looks okay. This is illegal. You're doing illegal math. Call the math cops on you. Radical function. Transformation approach. Cannot say how important it is for you guys to really know your transformations. Inside, outside, frontwards, backwards. You gotta know them. As I potentially screw this one up. No, of course not. Why is it square x? Okay, let's go ahead and let's do this one. Ooh, let's make this a little center. Okay, so we got 0, 0 as our first one. We got 1, 1. We got 4, 2, and let's do another one. We could do more if we wanted to. We could not. You know what? I think I'm going to do that. I'm going to do one more. I see a comment about y is greater than 0 be correct for 35. Greater than or equal to, if I'm remembering the one that... Yeah, greater than or equal to. Would have to be that. Okay, so equal to. I'm going to do one more. But why? Why, Mr. Morris? Why are you doing one more? Usually we stop after this. You're right, we do. But we usually don't divide by 4. That's pretty big. What I do notice is that that x-coordinate is divided by 4, and that x-coordinate is divisible by 4 as well. So kind of just like some I don't know, just mathematical decisions, right? Just, hey, I'm dividing by 4, and I really don't want to divide 9 by 4, so I'm going to choose some other ones. You can go as far as you really need to. Okay, we got 0, -1. I mean, sure, this is a quarter and 0. I don't even know if I'm going to get that on the graph, though. This one, though, is 1, 1, which is nice. This one looks like a nightmare, 9/4. Maybe that's okay. Yeah, that's not too bad. But this one's nice, 4/3. Let's put them on the graph. And you know what I'm going to put? I'm going to do this guy, and this guy, because you can see what those are really clearly. 0, -1. Boom. 1, 1. Boom. 1, 2, 3, 4. 1, 2, 3. Boom. Connect the dots. Watch out. Done. Missed it. Okay. Arrowhead. That's it. 3 marks. 3 marks. Psh, whatever. You do not have to indicate where the x-intercept is. You don't have to on the graph, or the y. You don't have to. You're good. It's always nice to do it. Like, we're not going to be like, oh, you're so wrong if you do this. But it's just not necessary. That's not something that we're looking for on radical graphs. What did I get it to be? 0. Not necessary. You don't have to do that. Okay. Oh man, we are blitzing through this. Solve algebraically. For the base graph of radicals, would we square root x or y? We would square root x, right? Y equals square root x. You're square rooting the x coordinates, right? I know that kind of seems backwards because like you do coordinates as xy, right? But y is equal to the square root of x. Always kind of say it out. It helps. Okay, solve algebraically. Darn tootin' we will. Straight up from the formula. I've memorized it. If you haven't, go look at it. That's cool. You'll get this, right? Equals 2n plus 7. Okay. Which one's bigger? You got to get rid of these factorials. That one is. I'm showing quite a bit of work, I would say. You could go right to just doing like the simplified version of it if you really wanted to. But showing it all. That's just 2, by the way. n minus 1 equals. We're going to times everything by 2. That's completely wrong. That's better. And let's go ahead and solve. Gotta do quadratics. I gotta pop that over as well. I gotta pop that over too. You can just kind of see what I did from that one. Yeah. N squared minus 5n minus 14 equals 0. What is 14? I'm thinking there is a 7 and a 2. You're right, there is. This is why factoring is important, right? It's always a skill. N equals 7, -2, and for that last half mark, guess what you gotta do? Gotta get up the old blue marker and cross off a negative n value. Can't have negatives in our combinations, or permutations for that matter. Can't have it. 3 marks again. Just giving them away. Okay. That's it for that one. Given f of x is equal to x squared minus 1 and g of x, explain why the domain hx. Oh, good. You should be able to do this one. This might, like, this is new, right? This is what we ended off just before the break with. But check it out. X divided by x minus 3. Explain why the domain has a restriction on this. I mean, straight up, right? Since gx is the denominator, x minus 3, g of x equals cannot be 0. Therefore, x cannot equal 3. That's it. That's really all we have to say. G of x on the denominator. Okay. Easy. Easy stuff here, okay? Giving away those marks. I think this is in the home stretch here. This is good. We're like 2 hours in, too, okay? Like 2 hours in. A couple more questions, you know, like there's some beefy ones, but like that's it, really. We're doing okay here. Okay, evaluate. Straight up, just evaluate exact values, right? You got to know your exact values. So these look all terrible, but it's not terrible. It's not too bad. There's some good ones up in this. Cos 2 pi over 3. We should know what that one is. Do I know what that one is? I think that's a half. Yeah, I think that's a half, right? Yeah. For which unit do we have to verify which answers were extraneous? Pretty much any unit, really. It can happen in logs. It can happen in square roots. It can happen in rationals. Anytime that there's that an x value that you get, if you solve for it, if it's coming from a function that has a restricted domain, and again, like the ones I was talking about, you should be checking. Like you should go back and be like, okay, can x actually be this if it's a logarithm, if I have a square root, if whatever, right? So yeah, square roots definitely, logarithms definitely, rationals. I don't know, that would make sense. Maybe absolute values too, that could make sense too. Just take a look at any of our functions that we've done that has like restrictions based upon it, like either x or y really, and that would be your answer. Regardless, let's keep on going here. Sine of negative 4 pi by 3. Now you could make this a coterminal, but I'm thinking that I'm just going to do this one in my head as well. That is... Oh, maybe I'm not going to do it in my head. This is right here, I believe. That way. So that's going to be a positive root 3 over 2. Yep. Oh, these are coterminal right there. Hey, that's cool. Could we say that h of x has a vertical asymptote? Yes, you could. That could be fine. Yep. You could say that h of x has a vertical asymptote as x equals 3. Yes, that'd be fine as well. Okay, so we have these as that one. Let's keep on going with that. Now we got our last one. Cotangent of 11 pi by 6. This one's not just good. We have it down here. So we're doing cotangent, which is 1 over tan, right? So 1 over tan. 11 pi by 6. Okay, so now the question becomes, what is tan of 11 pi by 6? We're in the pi by 6 family, so we're in the root 3 over 3 category, and we're in the fourth quadrant. This is negative root 3 over 3. If we do 1 over that, though, this is going to be negative 3 over root 3. Boom, boom, boom. Let's put it in. Negative root 3. Oh, woo, I already messed it up. Negative 3 over root 3. I was reading the wrong thing. We got sine to be root 3 over 2 divided by negative a half. Cool. We got some simplifying stuff to do. Boom. Boom. Negative 2, or 3 over 2 over negative 1 over 2. Hey, we got some more booms. Final answer 3. I'll just kind of put that over here. Root 3rd. Oop, nope. Or I screwed it up. Nope, I'm not going to do anything more. That's it. That was what my cotangent was. I'll put that up here. There. I can already send some questions coming up about that one. But there you go. Just evaluate exact answers. That's it. Okay. Solve algebraically. Log within a log. Okay. Oh, 1 mark. I like it. 2 to the power 2. So log 3x. 4 equals log 3x. Are you expected to know what 3 to the power 4 is? Yeah, you are. Yes, we have, finally. This is probably the last, not the last big question, but a pretty big question. I was waiting for one of these guys to pop up. Okay, let's handle this systematically here. Yep, let's get our period first. 2 pi divided by pi by 4 equals 8. Kind of prove that for yourself. Now we're going from -4 all the way to 8. All right, it's doable. 8, 4, 6, 2, obviously 0. -4, -2. Cool. All right. We have a midline at +1. And we're going up to a maximum value of 6 because our amplitude is 5. So 1, 2, 3, 4, 5, 6. My midline is 1. So 1, 2, 3, 4, 5, 6 as well. Okay. So I'm going to give this coordinate as 1. That guy up there is 6, I think I said. 1, 2, 3, 4, 5, 6. Good. -1, -2, -3, -4, -5. Okay. Sounds good to me. I just kind of am a fan of this. I'm going to do this. I'm going to do it very, very lightly. It's literally just a little marking tool. Sorry, not marking in terms of marks, marking in terms of where this midline is, just so that I can make a nice graph. Yes, you can. Yeah, that's completely fine. You can change the plot. You can graph it normally and then change the domain afterwards. Just make sure that you erase it and do your thing. I'm just doing it this way. That's just how I wanted to do the question. Yeah. We are doing sine. So that means that we're going to be starting at our midline when we do sine. We know that our ending is also going to be at the midline as well. We know that halfway is going to be our midline as well. We're going to be at our maximum in between our first two midlines. So we're going to go up 5. We're going to be our minimum -4, halfway between our second two. So we have 1 period right off the bat. Try to do this nice. I'm not going to screw this up. Okay. That is 1 period, right? And I am not going to, I'm not going to put arrowheads on this, okay? I'm not going to put arrowhead because it wants my domain to be cut off, so no arrowheads. Now I just have to work my way back, right? I got to be back at my midline at half a period. I'm working my way down, as you can clearly see. Watch out, done. Nice graph, if I say so myself. Good graph. Okay, that's it. Gotta know the values, gotta know the pattern, all that good stuff, right? I can give you 1,000 questions on these if you're like, oh, how do you do that? Let me know, right? Just did the characteristics of sine, did the maximum, did the min, worked my way back, done. 4 marks. I know it's a lot of marks, and it is a lot of work, but it is a 4-mark question that is probably one of the easier types of 4 questions to get if you know your stuff on that. Like, there's not too much. It's just kind of like this, connected up, done. Okay, given the graph of f of x, boom, sketch the graph of f, absolute value of f at -x. Oh, interesting. So we have an absolute value and we have a horizontal reflection. Which one would you like to do first? Well, I'm going to do the stuff on the inside first. I'm going to do the -x. It would not matter which way you did it before. It would not matter. You could do it either way. So instead of this going over here, 1, 2, 3, boom, boom. So that would be f -x. And now I'm just going to pop all these guys on the top. So let's go like that. Let's go like that. 1, 2, 3. 1, 2, 3. Let's make sure that, yeah, that goes like that. There we go. Just making sure everything looks okay. Yep, that's good. That's it. Why does it seem odd? No, it doesn't. That's good. Yeah, it's okay. No, that's good. I'm checking the marking guide though. What was it? 43. I want to check the answer for myself here. I don't know why I don't think it's right. No, I'm good. Okay, yes. See, I knew it was right. I just went. Okay, good. All right, continuing on. Almost done. Savannah, that's a fun name. Use the graph. Y is equal to to sketch the graph of the square root of x. Her solution was given below. Describe her error. I'm gonna plot out some things that are really nice about this. First off, this is totally correct. Having the square root function above the original function is perfect, and then below it is perfect as well. All of her coordinates are awesome. She disregarded the negative y coordinates because you can't take out square roots of negative y, but the thing that she did, describe her error. Right? Describe her error. She did not. Restrict. Restrict the domain. She did not restrict the domain. You could put some other stuff too. You could say like, she continued the graph on past where f of x was cut off, or when f of x ended, she continued on the graph. I think there was some discussion around if students said that she put an arrowhead on, that was wrong. That was why it's wrong. The arrowhead is part of why she's wrong, but she continued it past it, right? Her arrowhead is over here. So the arrowhead is wrong, but everything before the arrowhead is wrong as well, up until that point. She should have stopped it at her point there, but she did not restrict the domain. That's probably the most concise way to say what her error was. It stopped. What stopped? Uh-oh. Are we okay? Hold on, I'll send a message real quick. It says that it is working. I'll wait for a second. I'll just kind of pause the stream right now. Okay, it's back on. Not really. Okay. Okay, I will restart it. It freezes occasionally, but it's fine for me. Oh, okay. I don't know. If it's a really big, might be a problem on their part. Okay, I think it should be okay. I know that the freezing, I think that's just because of the crappy camera. I don't think it is. It is now. Okay, all right. We won't restart it. We'll keep on going here. We're almost done anyways, guys. Okay, let's keep on going. Determine the exact value of sine 13 pi over 12. Check this out. It is, waboom, 3 marks. You gotta do some work here, right? That's not an exact value. You don't know it, right? And it wants an exact value. Immediately, you should be like, so the graph. I'll get to your question in a second. Immediately, you know that there's got to be more work that needs to be done. Look in your formula sheet, there's stuff that you can do. Okay, so if the graph that's shown doesn't have arrowheads, we wouldn't put arrowheads because, correct. We would not put the arrowheads because that implies that there aren't restrictions, essentially, right? And on that, if there is an arrowhead, it means it continues on forever, but if there's a restriction on the graph that there isn't any arrowheads, or you can't have arrowheads or something, you can't have arrowheads on your graph that you produce. I don't know, that kind of seems like a shaky answer, so we can figure that out afterwards as well. But if you haven't figured this one out, it's got to be the sum formula. You got to do that, right? At this point, I'm just going to kind of start labeling out some stuff. I think I remember this formula. It's sine alpha cos beta plus sine beta cos alpha. I haven't looked at my formula sheet. I'm going to go take a look real quick. Yeah, we're good. Yep. Probably. Crap. Yeah, we're good. Okay. All right, so let's keep on going here. We need alpha plus beta to be equal to 13 pi over 12. There is a lot of ways that we can do this. My absolute, like, hey, try this out, is to just get some values that add up to 13 that have a denominator of 12. That we're going to be able to reduce afterwards, okay? So here's a couple of things that I know. We can do 6 pi over 12 plus 7 pi over 12. That would get us to 13, right? But there's a problem. What's 7 pi over 12, right? So that's not going to work. So let's do another one then. Let's try something else. Maybe like a 10 pi over 12 plus a 3 pi over 12. Okay, that might work. Well, let's see if we can do some reducing here to see if we can get it into something that we know. Well, this is a 5 pi over 6. We know exact values for that one. And this is a pi by 4. We know exact values for that one. There are other combinations as well, right? So don't feel like you're pigeonholed into this one. So this is going to be my alpha. This is going to be my beta. And check it out. Just gonna pop it in. So like kind of heavy on like setup, I would say. But once you get the setup, and assuming that you know the exact values, you're pretty much home free at this point. Just gotta plug it in. You know, dot your T's, cross your I's. Okay. Let's do the exact values over here. Sine of 5 pi by 6 is in the second quadrant. It's our 30-degree angle for our pi by 6, so we're at a half. That's quadrant 1. We got a root 2 over 2. You can also say this is 1 over root 2. That would be acceptable as well. Plus root 2 over 2. And then we have cos of that angle, which would be negative root 3 over 2. Luckily, everything is common denominators. Awesome. Equals root 2 over 4. Don't say 2, because we're not adding these, we're multiplying. Negative root 6 over 4. And we get our final answer. And we leave it be. We leave it be. Okay. Cool. That's it. State the equation of the horizontal asymptote of this. Wait, hold on. We did a question like this earlier where we had to make one up. So pretty easy actually. Horizontal asymptote, degrees the same. That's the easiest mark that we're going to come across this exam, I think. Done. Equation, right? And HA equals is not an equation. Y equals is an equation. Here we are. Nice question here. Nice question. Lots to do in this. Lots to do. Yeah. We're going to factor right off the bat. Can you flip back to the other page quickly? You're going to have to give me the page number because I don't know if you mean this one or if you mean this one, but I'm going to assume that you mean this one. And I will leave it here. You can always kind of look the video later on. Is there a question that you have for us? Let me know. I am going to continue on with the other one though. Okay, I'm going to continue on with the other one. Remember, these are all available online. I did upload them on the Google Classrooms as well with a marking guide too. So you can always take a look at those. Okay, anyways, back to here. Minus 10 over. It's freezing again. Crap. Okay, I will restart the stream. Stop stream.